Today we'll be talking about systems of equations, and when we talk about a system means a bunch of things working together. So it's more than one thing. In the case of what we're talking about today, we're just going to talk about two things. So it is more than one thing, but we're not going to extend it to three things. So systems means more than one. And remember that an equation is something that has an equal sign where each side is balanced. So that means it's going to have an amount here, and that should be the same amount if you simplified. When we are graphing two equations, we want to find the point of intersection. Two ways to say that is point of intersection, and I like to abbreviate it POI, or you can call it a solution to the system. So either way, point of intersection or solution to the system. So we're going to look at these two equations, y equals 3x minus 2 and y equals 4x minus 4. Remember, this is our slope, our rise over run, and this is our y-intercept, where it hits the y-axis. So in this case, our slope is 3 over 1, a rise of 3, a run of 1. And our y-intercept is negative 2. In this one, our slope is 4 over 1, rise is 4, run is 1, and our y-intercept is negative 4. So let's graph these and see where is their point of intersection. Where do they hit one another? And that point at which they hit will make both equations true. So we're going to find the coordinate point where the two lines hit. So let's start with our y equals 3x minus 2, and I'm going to change the color, change it to pink. And let me just label that this one will be the pink one. So here's our pink line. So remember, I'm starting at my y-intercept at negative 2, so I go down 1, 2 on the y-axis, and I put a dot. Now I'm going to rise 3 and run 1, so I go up 1, 2, 3 over 1, and I can do that again if I want. Up 1, 2, 3, and over 1. So I'm going to draw as straight as line possible as I can through these points. When I'm on this, it's a little hard to draw those straight lines. Now let's look at our other equation. And let's make that one green. So I will circle the bottom one in a lime green. So I'm going to start at the negative 4. So I go down to negative 4 and I put a point. Remember, that's over 0, down 4. And then I'm going to go up 4 for my rise, 1, 2, 3, 4, and over 1 for my run. So I have a point right there. I'm going to do that again, 1, 2, 3, 4, over 1. Whoops, I'm a little off there. So I'm going to go up 1, 2, 3, 4 over 1, and it hits right there. It looks like it hits there, but actually that line, because it's not as straight as I like it to be, it's not hitting that. Let's see, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. So I'm going to draw my line once again. Remember, it's hard to draw straight lines on this program. And it's going to go up and it's going to hit at this point. That's where the two lines intersect. That point is over 2, up 4. So I have an x value of 2 and a y value of positive 4. This is my point of intersection, or I can call it my solution to the system. Let's see if those points work. So I'm going to go over here, take my equation, y equals 3x minus 2, and I'm going to plug in the 2 and the 4 and see if it makes it work. So my y value is 4, my x value is 2. 3 times 2 is 6, 6 minus 2 is 4. That one checks out. Let's try it on the other equation. It should make both equations true in order to be a solution to the system. So I'll put my 4 here, my 2 here. 4 times 2 is 8. Oops, apologize, put a 4 there. 4 times 2 is 8, minus 4 is 4. It checks out. So that is the solution to this system, the point where those two lines hit. We're going to work more with this, but today I just wanted to give you a glimpse of what we'll be doing.